And I'm definitely seeing audio. Are you seeing it? You get a new link? Oh. Yeah. It'll probably be better without the mask. Yeah. We just have to, we gotta send out a new link. So sometimes I hate technology. Okay, is it, can you see it on yours? Oh, you got it, okay. Still no sound? I can hear the audio. Take care of me. Okay. Alright, let me figure this out. Okay, what about now?
Hello, hello, test, test. 1, 2, 3, test, 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 test.
Okay, what about now?
Test, test. 1, 2, 3, test, 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 test.
I don't know how you want to handle that. They're probably hearing me off my microphone on my laptop.
Test,
And I'm
test.
switching them
Hello.
out.
Good morning, test. Hello, test, test.
I'm hearing you off my microphone.
Test, test. Test. Hello, test, test. Hello, hello, test, 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 test. Hello, hello. Good morning, test, test, test. Test, test, test. Hello, test, test. Hello, good morning, test. Test, test. 1, 2, 3, 4. Test, hello, test. 1, 2, 3. Test, test. Hello, hello, test. 1, 2, 3. Test.
So frustrating.
Hello, test, test. Hello, good morning, test, test, test. 1, 2, 3, test. Hello, test. 1, 2, 3, test, test. Hello, test, test. 1, 2, 3. Test. 1, 2, 3, test. Good morning, test, test. 1, 2, 3. Okay. Yeah.
Alright, we're gonna have to really connect.
Where should I speak to?
I'll just hold it close to you.
Okay.
So you
Right,
can,
they said
can
it's
still
better.
see. Yeah, they can still see you here. Okay.
Okay. Can you hear me clearly? Oh, okay. Okay. So, my name is Marlon. I work for Control System, TCS, and I'm part of the team that work the design of this control, basically the GCP control. As you know, previously we had a GCP control there, and the quality was quite different. So the main difference is that you have now two common power, Tico, and that's Tico 2. We still have two generators, one and two, and also the new installation includes a tiebreaker here on the middle. We're going to navigate through the main components, and so we're going to also see what happens in the case that one of the Tico is lost, either Tico 1 or Tico 2 or both of them, and what you're supposed to see happening in auto, and in an emergency or in a non-common situation, you can go manual and do some manipulation of the system. I'm gonna go and I'm gonna show some presentation. We're gonna include those presentations later, and in those presentations, you can see images, and it's gonna be more clear sometimes for you to follow some nameplates and stuff. First, we're going to navigate through the components. We have two main components, which are the EasyGens. We have EasyGen number 1 over here, and EasyGen number 2. And the EasyGen is a component that basically take care of the engine. It can start the engine, stop the engine. And it's going to talk to the other EasyGen, and it's going to do load sharing. Load sharing means, share the two generators with the same amount of load. So one is not going to be overloaded, and the other one is going to be, working idle. So the EasyGen take care of it. And 1 second, it's good. I can hold the laptop if you want. Can I close it or?
I wouldn't close it.
No. Okay. And where's the microphone? It's just let's see. Where's the microphone?
It's probably here.
Oh, okay. Okay, maybe it's over here. So you guys let me know, because we're trying to overcome some of the noises that we have here, and trying to see what's the better microphone that we have. I'm gonna try to hold the laptop. So, as I said, the main components are the EasyGens, which take care of the engine, and the circuit breaker. So it talks to the engines there, to the caterpillars. We have the caterpillars in another building, and we have some cables connected from here to there, and they talk to the caterpillars to run it, to control the speed and the voltage, and also controls the circuit breaker here. Yep.
I can hear you.
Okay.
Can you start over again and introduce?
Oh yes, of course. Can I do something? Can I put the presentation here, so I can at least not having the tablet, but the presentation here. Right? I believe I sent you the presentation via Gmail. to your email. Great, thank you. Hello, hello. There is a noise. Hello, hello.
Okay, you're good.
Good. All right. Okay. I'm gonna start over. So, good morning. My name is Marlon Trujillo, and I work with GCS, Governor Control System, and this time we're gonna talk about a little bit about the GCP, the cabinet. We have some. There is a noise. Hello, hello, hello. Is it? Is that?
So sorry, everyone watching.
Video.
Rick, I just now we're getting feedback. Okay, let's try this again.
Hello, hello, hello. Can you hear me clear? Okay, cool. Let's start over. So my no problem. It's a little noisy over here, so it's a little bit hard to overcome these fans and industrial noises. My name is Marlon. I work I was part of the team that designed this cabinet and the whole system. I work with GCS, Governor Control System, and this time I'm here to explain a little bit of what we have here on the top and what you're supposed to see when one of the T codes or the utility fails, and what are the options you have to set the system to manual and do additional operations, or basically to have an option when the ECGens are not available. So starting with the main components, we have the main components as the same as the previous cabinet, because this cabinet is a replacement basically from an old cabinet based on the same technology, the woodwork technology, but with an old component. And also we did some topologies changes. By this I mean there was before there was just one incoming power, one utility, the TICO, and with this new configuration you have TICO 1 and TICO 2. And also we included a tiebreaker in the middle, so you have options to back up the power from either TICO 1 or TICO 2. And we still have two generators. Those are the Caterpillars, that they are in another building, and that's it. It's quite different than the previous topology, the previous switch gear, but this time it's all about give you more options and to have a better system. So the chances that you lose power are much less. So talking about the main components, we have ECGens. We have two of them. ECGen 1 and the ECGen number 2. Right? We have LS5s on the top. This is the LS5 for TICO 1. This over here is the LS5 for the tiebreaker, and this LS5 is the LS5 for TICO 2. Those are the main woodwork components, and we have over here this is to synchronize the system manually. We have some pilot lights on the top indicating status, warning alarms, shutdown alarms, and when the system is not in auto. On the bottom we have this row is to manual control. We have the emergency e-stop. We have two emergency e-stop, one for G1 and the other one for G2. They are based on the same layout, so it's based. This part over here is the same for each generator. On the bottom right here, we have the main switches where we can set the system to work on manual or auto. We can simulate some fails. We can reset alarms. We can change priorities. I'm going to explain a little bit later about this. We have the option to retransfer. I'm going to explain this a little bit later. And also to set the control to local or remote. This is basically give you the option to control the system by using these switches or maybe using the DCS via Modbus. Inside of the cabinet we have right here we have the main components on the door. As we said, this is the wiring for each component. We have two doors. They are like mirrors, so they have the same components wired. On the back, we can see those sharing modules. Those are woodwork, and those are basically the ones that are in charge of the manual control. They help the manual in a way that the EasyGen can be outside of the picture, and so the load sharing is being done by these components. On the top we have power supplies, some circuit breakers, right? Protection for all the wiring, main terminal blocks, IKDs. These are basically remote IOs for the EasyGens, so it can expand the amount of inputs and outputs with this control over here. We have some relays, normal relays, external relays, and some PLC over here, mostly for communications and Modbus. Jesse can talk about this more about, and some protections over here. Those are woodwork protections. Those help for manual control. Those are basically the main components. I'm reading here my presentation. We can maybe add this presentation to the video, and so far I'm gonna go through. I'm reading sheet number 3, so I describe the main components. And let's talk a little bit about the EasyGens right now. Let me close this. All right. So EasyGens, as you know, this is gonna be a different presentation. I'm just gonna talk an overview of the control. It's not gonna be like a training for the EasyGen, but basically the EasyGens can do. I'm reading at the sheet number 4, by the way. The EasyGen can do voltage measurement, current, active power, which is kW, kVAR, which is reactive power, power factor measurement, synchronization, load sharing, and so on. It's a configurable device. You can access to all the settings via this panel. It's not touchscreen, so you have to use those buttons over here, and you can access to all the settings, as I said, navigating through all the screens that it has. Right, you can see more measurements. You can see values coming from another device like the LS5, and you can operate basically from here the engine. This side over here is disabled. This side is to change the mode to manual, stop, or test, or whatever. But we are using these switches instead, right? Because this application has a different configuration than the default one. So we use these switches. So taking in account these buttons over here are disabled. You only have these buttons available to navigate through the screen. The second EasyGen is the same, right? So on the front you can see generator data and the bus bar. The bus bar, I don't know if you can see here, is saying 13.4 kV. That's the voltage the EasyGen is seeing on the bus bar. The bus bar means this is the generator, this is the circuit breaker, and the bus bar is this one over here. So it's open, as you can see, right? You can see the pilot lights on the top. Green means open and red means close. So the generator number 2 is open, and it's looking at the bus bar, and it's having the measurement of 13.4 kV at 60 hertz. So that's normal. And on the side of the generator, there is no voltage or frequency, which means it's stopped. The same for the other EasyGen. So it's all the time waiting for any failure or a loss of one of the Tico to react. Right now, all the system is in auto. That's how it's supposed to be working, and it's overseeing and it's looking at the voltages from the two Ticos to see if there is any failure. On the LS5s, so the LS5s is basically monitoring each Tico. It has connections to see the voltage and to see the current, and also can open and close the circuit breaker, which means that, for example, if we have one Tico lost, the first action is to open the circuit breaker so the system is going to be isolated from the outside. That procedure is being done by the LS5, not the EasyGen. But the LS5, it is talking all the time with the EasyGen, so the EasyGen knows when there is a failure and when the LS5 is opening the tiebreaker. This is the Tico. The same happens with the tiebreaker. So in any conditions in auto, this LS5 is going to open or close the tiebreaker. The same with the Tico 1, control and monitoring and controlling the Tico 1 can open the generator, the Tico circuit breaker, and it's going to measure all the voltage and the frequency. Those are the EasyGen control and the LS5s. Looking at the presentation, we're going to talk about a little bit about we're going to go through the sheets, and as you can see on the sheet 21, you're going to see a topology, right? And it's basically the same topology as you're looking at the front right now. We have these red lines which indicate the bus, basically the switch gear as we have it on the back. This little triangle over here indicates that the load is over there or the load is over here. On the diagram you can see how the EasyGen is talking to the Caterpillar CDVR, which is located in another building, and it's talking also to the Adam control, so it's also in another building, and the EasyGen is talking to the generator circuit breaker, and the LSM on the top of the EasyGen is the load sharing model. This one over here. So that's the LSM. What we have in there is that basically, if you follow the lines, you can see that the EasyGen is gonna go through the line that says auto, and the LSM, they go through the line that says manual. So it's like a switch over between the EasyGen and the LSM when we have it on auto or manual. Close this again, and so as I said, we have two main modes. I'm looking at the sheet 26. Manual and auto. So in manual, I'm gonna read this back to you, and so you can be on the same page and explain a little bit more. In my manual, the operator has the capability to open the circuit breakers, start the emergency generators, G1 or G2, close the main services, over here Tico 1 or Tico 2, unless there is a protection lockout. The protections relays are on the back. I don't know if you can show here. So we have all those relays on the back, and if we have any failure on those relays, the system is not gonna do any automatic operation, because that means there is a dangerous situation. So manual. Also, the closing of the circuit breaker should be initiated by an operator. That means that, in manual, if there is a blackout, the generators are not going to start by themselves. We need to go here and initiate the running of the generators. The same happens with the circuit breaker. If the generator is running in manual, the circuit breaker is not going to close. So we need to come here and close the circuit breaker after the generator is stable. Usually that's around 20 seconds, and the DCGen, if it's available, is going to help you saying that the generator is stable or not. In auto, so in automatic mode, all the engines, GCB, MCB, tiebreakers, they are operated, by the automatic mode, which means it's not waiting for the operator to do any action. Navigating through the different switches and pilot lights, that's something important. So you can review this video and understand what the pilot lights, what the functions are. Let's talk about this, and I'm gonna follow the same presentation. It's gonna be on the sheet 27. You can take a look on that, and you're gonna see more details. So we tried to separate all the layout in groups. So we have the group number 1 over here on the top. Right, this is group number 1. We have 3 pilot lights and 1 buzzer. And basically the first one is to indicate the system is not in auto. You can press the LED, the pilot light, to test if the bulb is working good. It doesn't mean that it's gonna do any action. It's just to prove that the light is working. So system not in auto. When the system is in manual, you're gonna see this pilot light like this. Shutdown alarm. If there is any shutdown on the system, this pilot light is gonna be active. On the presentation says a class F alarm. This means that for DCGens and LS5, everything is classified with letters, meaning a class B or A is an alarm. Class B, C, D, E is an alarm. They have different differences in the way that the one shows the alarm on the screen, the other one is activating the buzzer, but the main one is in class F, which is a shutdown. So whenever you see a class F alarm, that means it's a shutdown. If there is a class F alarm, this pilot light is gonna be active. We also have a warning alarm. So it says this alarm do not interrupt the unit operation and indicates there is a class B alarm in the system. So this is the class B alarm. And over here we have the buzzer. This is just to make us a sound that there is something wrong with the system. So that's the group 1. The group number 2 is the LS5s. So I explained a little bit about the LX5s. They are basically monitoring the T code and doing actions about closing and opening. At this moment, it's closed, the T code, but it can be opened. right? You can test the pilot light if you want to see if it's working or not. Just the bulb. So we have one TCO closed, TCO 1. The tiebreaker is open at the moment, right? If it's closed, you're gonna see the pilot lights red. I can press the pilot light to test the light is working. And also we have the TCO 2 over here, closed and monitored by the LS5. The same, you can test functionalities and you can test the light. So that's group number 2, and so we're going to talk about group number 3, which are the circuit breaker control. We have basically 5 circuit breaker control, and this is basically to open and close the circuit breaker in manual, and to show the status of the circuit breaker. The circuit breaker is, the connection between one side or the other in a way that is made fast without risk. And the circuit breakers are located on the back. I don't know if you can see it there. Here on the bottom we have the circuit breakers. So this is local, and we have also control over the circuit breakers here on the cabinet, right? So from here in manual, you can open or close the circuit breaker. I can now open it, but I'm not gonna do it obviously because this is working right now. But it's basically comprised of 2 lights, open, closed, and the circuit breaker. The circuit breaker have 2 indications, close and trip. So in a little flag, so you can trip it or close it. You have 5, as I said, 2 TCOs, 1 tiebreaker, and 1 for each control generator. Okay, I'm looking at the sheet 29, and I'm going to explain a little bit of the group number 4. And we have the group number 4 comprised of EasyGens. The EasyGens, as I said, is the main generator control. It has all the configuration and programming, and basically talks to everyone. Talks to the caterpillars, controls the voltage and the frequency to the caterpillars, and talk to each component here, meaning the TCOs, the tiebreakers, so it knows what's happening all the time, and it can take different actions depending on what's the available source. The main programming resides in these 2 controllers. It's the same control, right? The same model, but you cannot swap it. You cannot interchange the EasyGen because each EasyGen knows where is it, and so the software has to be different from one or the other. The same happens with the LS5s. The LS5 you cannot replace them and swap them, because even though the model is the same, each LS5 is programmed in a different way. On group number 5, we have this row over here. This is the emergency e-stop. So what the emergency e-stop does is it's gonna show an alarm here, explaining what happened and recording when the emergency e-stop was pressed. It's gonna flash. Here we're gonna see a flashing red. We're gonna have the horn active. So there is a noise. There's gonna be a noise here indicating there was a e-stop. It's gonna open the circuit breaker, isolating the engine, and it's gonna stop the engine. So basically, it's gonna open and stop the engine and show alarms and activate the buzzer. It's active all the time. It's active manual or auto. And here on the top we have this is the auto mode. It's available when the system is in auto. Through this switch you can stop the engine, do a test offline or a test online. That means that if the system is in auto over here, this switch is available. If the system is in manual, right? If you try to change this, it's not going to affect the system. So, if the system is in auto, you can do off, auto, test offline, or test online. The test offline is to start the engine and not closing the circuit breaker. The test online is to start the engine, synchronize, closing the circuit breaker, and opening the T-code. So it's a transition between the T-code and the generator, a safe transition. And it's a close transition, 100 milliseconds, but a close transition. So if the system is in manual, if you go here and change this switch to manual, you can use these three switches on the top. So this switch is on auto, these switches are available in manual. You can run the engine if you switch this position to the right. You're going to run the engine. You can adjust the voltage or you can adjust the speed over here. So manual, auto. Can you hear me? Okay, I'm sorry about that. We had a disconnection of the power for the laptop, so it turned off. Things that happened here in the industrial area. So we were talking about the groups, right? And the group number 1, 2, round 1, 2, 3, and we are gonna continue with the group number 5, which is over here. We talk about the emergency e-stop. We talk about the auto mode, which is only available when the system is in auto. We talk about the 3 switches for main control, for manual control, to run the engine, to control the voltage, and to move the speed, which is the frequency. That's I'm on the sheet number 31, by the way. So you can see more details about the switches over there. But these are the main switches for manual control. On sheet 32, you can see the group number 6. Group number 6 is comprised of all of those switches, and basically this is the main one. It has this label over here because it's important to remember that the type CB3 is in auto all the time. The type, this is meaning that this component over here needs to be in auto. As you can see here on the LED, it's in auto at the moment. You can transfer this LS5, this control to manual, but it's gonna indicate an alarm that the system is not in auto. And the reason is that in auto, it's gonna follow and accept the commands coming from the EasyGens to close and open it. In manual, it's gonna disregard any external commands, and you have to do everything by pushing the button. Okay, so talking about the group number 5, we have the system auto or manual. We have the 2 TICO fail test. These switches, what it does is when you put it on, it's gonna tell the system to do the same procedure as the TICO 1 is failing, meaning this circuit breaker is gonna open, right? And this side of the bus bar is gonna be blackout. The generator is gonna run. It's gonna go for an stable operation. Once it's stable, it's gonna close the circuit breaker and it's gonna energize all of this area. But this means that you are gonna go to blackout. This is not desired, and this is just for testing the functionalities and this situation it's recommended to, instead of doing a field test, doing an online test. With the system in auto, you go and select your online test, and it's not gonna do a blackout. The online test is gonna run the engine with the main breaker closed. It's gonna synchronize, close, and then opening the TICO, so the load is not gonna be off. Okay, so continuing here, we have the TICO 1 and the TICO 2, so you can do the same for TICO 2. Opening the circuit breaker, going blackout, and backing up with the generators. You can do the reset and silencing of the buzzer with this button. You can change the priorities if you want a priority on utility or generator. I'm going to explain a little bit more about this in a moment. And you can do the auto retransfer off or on. I'm going to explain a little bit about this in a moment. And you can select if the system is going to accept local or remote controls. Remote controls are coming from the SCADA, and the EasyGen is accepting the remote, basically. Remote commands. So group number 7 on sheet 34 is about these components right here. Synchronizing lamps, the synchroscope, and the sync source. This is being used when the system is in manual and you want to synchronize the generator against the bus bar. So when you do that, basically you select which one is going to be synchronizing, and then close it manually when the synchro indicates you can do so. So now that we navigate through all the components and see what basically the main functions of them, we're going to talk about what you can expect when something happens. And I'm going to jump a little bit on the presentation, and we're going to go through the sheet 37, which is loss of both mains. This means that TICO 1 and TICO 2, both TICOs, are off. Basically, something happened on TICO or the utility, and you have a power blackout. So, following this, the table, it says that basically the system is in auto, and both TICO fails. So the condition is that the circuit breakers, they are not locked out. The circuit breakers are the one on the back that we saw in a moment. They have to be healthy and operating, in normal conditions, and that's one of the conditions for the auto to be working. If that flag is okay, and we lost the two TICOs, we're gonna follow this procedure. Basically, CV1 and CV2 detect the failure. CV1 is this one, TICO 1. As you can see here on the nameplate, it has a name. So TICO 1, CV1, and CV2 are gonna detect the failure, right? It's gonna go through a delay, so it's not gonna be an immediate action. Sometimes you have a power failure that is only an operation that they are doing there on the utility, and it lasts 1 or 2 seconds. So there is no reason to just run the generators and doing a backup if it's something real quick. So if the time expires, we are gonna open the LS5. They open the circuit breakers, both of them. The generator is gonna start. So here on the screen, you're gonna see the generators is starting. Right, the generator will go to rated speed and rated voltage. Right. Once the generator is stable, it's gonna close the circuit breaker. So you're gonna see this pilot light red, right? And the tiebreaker is gonna be opened. You have the option to close it, but in a normal condition, this is gonna be open. So let's run through it again. So we lost one TICO. After a delay, this is gonna be red, meaning green, meaning it's gonna open. Generator is gonna start. It's gonna go rated speed and rated voltage. Once it's stable, the circuit breaker is gonna close, and this pilot light is gonna go red. The tiebreaker is gonna keep green, which means open. And the same happens on this side, because this is loss of both mains. Basically, this is gonna open after the delay. Generator is gonna run, go rated voltage, rated speed. After it's stable, it's gonna close this circuit breaker, and it's gonna energize this side of the bus. The tiebreaker is gonna remain open. That's what's gonna happen on the loss of the two TICO. That's the main or the most common scenario, but it's not the only one. Now let's talk about the loss of one main and the actions of the auto action when losing one main depends on this switch over here. this backup priority. So right now we have the priority on generator. How do I know that? Because I'm here on the top. We have these two pilot lights indicating where the priority is right now. So let's go through it and see what happens when you lose one Tico and the priority is on generator. I'm gonna look at the sheet 40. So basically, it says the utility power failures fails on one of the services. Let's say Tico 2. If Tico 2 fails, CB2 is going to detect the failure. After the delay, the same as before, it's going to open the main breaker, right? The tiebreaker will remain open. The generator on this side is going to run and it's going to close and energize this side of the bus. The other side is going to remain on Tico 1. Right? That's the priority on generators. The priority on the type on the utility means that if you lose Tico 2 after a delay time, it's going to open this circuit breaker. It's not going to run the generator, but it's going to close the tiebreaker instead, energizing this side of the bus with Tico 1. So that's the main difference of the priority. You can change the priority over here. So with the generator, priority on generator, if one side fails, it's going to run the generator and it's going to energize that side with the generator. And if the priority is on utility, the tiebreaker will close and it's going to energize using the remaining Tico. To go back to Tico, when after a healthy delay is expired, the healthy delay is meaning to confirm the Tico is healthy. And let's say and follow the same example. If Tico 2 fails, and we have, for example, the priority on the generators, this generator is going to run, it's going to close and energize this side of the bus, and this is going to remain open, and the tiebreaker is going to remain open. But what happens when the Tico comes back? Well, first the system is gonna wait for 1 minute to see if it's really an unstable situation, and then it's gonna wait for the action of the operator to go back to Tico, and this action is controlled by this switch over here, the auto retransfer. So if it's enough, the system will run with the generators until you decide to go to on. When you change the switch position to on, what's going to happen is the generator over here is going to synchronize against the Tico. It's going to close Tico. In this case, Tico 2 is going to close, so it's going to be in parallel for a short time. It's 100 milliseconds, and then it's going to open the generator. This means it's going to transfer power from generator back to Tico. After this happens, you can go to the auto retransfer switch and put it back to off, which is the normal condition. So now we're going to talk about the tests that you can apply to the system. We have mainly this switch over here to do the tests, and to be able to use this switch, as I said before, we need to have the main switch on auto. Having the main switch on auto, we can go here and do a test offline or test online. Let's talk about the test online first. I'm on the sheet 42. So, first of all, we need to set the priority to generators to do any tests. Right? So we change this. If it's on utilities, we go through generators and we confirm here with the pilot lights we are on generators. Then confirm the system is in auto, of course, and select where you're gonna initiate the test. If you wanna initiate the test remotely by the DCS or the SCADA, or you wanna initiate the test from here. If you're here, you shall select local on this switch. Right now it's on remote. You can switch it to local, right? And then you can select the position of the switch to be online test. What it's gonna do is, as I said before, it's gonna run the engine, go stable time, close it, and after 100 milliseconds, it's gonna open the T code. It's a closed transition where you are not gonna have blackout of the system, basically. That's online. To do the offline, you follow the same procedures. You go with the system in auto, you confirm you have local control, and you go to the auto mode switch and select test offline. What it does is going to run the engine and not closing the circuit breaker. So it's going to just run the engine and leave the engine running in rated speed, rated voltage, so you can confirm the engine is working and everything is ready to be back on. And with that, we can conclude the presentation. If you have any questions, please let me know. We are gonna accept, I believe, emails or texts to if any of you guys have any question on this.